The lower right-hand corner of a long piece of paper 6 inches wide is folded over to the left-hand edge as shown. The length of the fold depends on the angle theta. The wider the angle theta, the longer the length of the fold L. Show that the length L is 3 over sine theta times cosine squared theta. The question asks us to come up with a relationship or an equation that relates the length L with theta. In order to use theta and L, we would need to use the triangle at the lower bottom. Using this triangle, we let the length of the opposite to the angle theta be x. Then we see the sine of theta equals x over L. So L is cross multiply, we get x over sine of theta. But we want this L to be 3 over sine of theta times cosine squared of theta. What this means is that we need to somehow show that x equals 3 over cosine squared theta, because L is 1 over sine theta times x, so x has to be 3 over cosine squared theta. The number 3 in this expression has something to do with the width of the piece of paper, 6 inches. We let x be the length of the side of the right triangle on the right hand side. Observe that on the left hand side, we also have a right triangle in the lower bottom corner. The side of this length is therefore 6 minus x, because the entire width of the piece of paper is 6 inches. If this is x already, this has to be 6 minus x. In order to use 6 minus x in the lower left triangle, we need to know the angle, an acute angle in this right triangle. But observe that in the triangle on the right hand side, if we call this angle alpha, then alpha is pi over 2 minus theta, because the two acute angles in a right triangles are complementary angles. They add up equal to 90 degrees or pi over 2. From the symmetry of the fold, if this angle is alpha, then the angle in the triangle that is next to it is also alpha, because it is the fold. Again, if this is alpha, when we fold it, this angle is also alpha. Because of those two angles being alpha, we see that this angle is therefore 180 degrees or pi minus 2 alpha. But since alpha is 90 degrees minus theta, we have 180 degrees minus 2 times 90 degrees minus theta. This is 180 degrees minus 180 degrees plus 2 theta. So this is 2 theta. Although this is not drawn to scale, this angle in the lower right triangle is 2 theta. So we will use the double angle formula. Also, observe that if this length is x, by symmetry, the length of this segment is also x because of the symmetry of the fold. So since this is x, we have cosine of 2 theta, which is the angle in this right triangle, equals adjacent, which is 6 minus x, over the hypotenuse, which is x. Keep in mind that the goal is to show that x equals 3 over cosine squared of theta. So we will rewrite the double angle formula of cosine of 2 theta using cosine squared only. Cosine of 2 theta is 2 cosine squared theta minus 1, using the double angle formula. And on the right hand side, we have 6 over x minus x over x, which is 6 over x minus 1. We then cancel the minus 1 on the left and on the right hand side of this equation to get 2 cosine squared of theta equals 6 over x. Cross multiply, we have x equals 6 over 2 cosine squared of theta, which is 3 over cosine squared of theta, which is what we want. We then pick up where we left off. We obtain L equals x over sine theta, but we just show that x is 3 over cosine squared theta, and we still have sine of theta in the denominator. Thus, we show that L equals 3 over sine of theta times cosine squared of theta using the double angle formula.